hear me in the back. If not, I can just get the headset if this is really needed. So you have the password here. So just to be sure that everyone has a connection to the internet. So before we start, let me. Well, the workshop is divided into two sections. The first section is I will just tell you some more about the theory behind Chatbots, behind NLP, and then we will go to the Jupyter Notebook, go through some examples, how to actually use what kind of methods we have, what kind of architectures we have, and so on. So just go through. It's only 90 minutes, so it's not, the topic is huge and it's just 90 minutes. So I try to, say as much as I can cover topics, so many topics as possible, but I know it's not enough. But I try to do my best to, get an idea what is it about. So, yeah, cool. First things first. So, probably you have the container, the image of the Docker image, right? You have downloaded before. Don't try to do it now. If you haven't done it before, it's about, 5 gigabytes of data you need to download. That's why I asked to do it before. But if not, don't worry, you still can attend the workshop. I have a plan B, I would say, a second scenario. All the libraries that you actually need, even more, are included here. You can actually, it's one of the images that I'm using for my workshop. So not all libraries that we will cover today are here, as well as some APIs for some, for Slack, for Skype, for Facebook Messenger, and so on and so on. That we can also use to integrate our chat. The second thing is, if you have already the container, so we have the image and we have created the container, you can download the notebook here. It's on GitHub, it's public. GitHub.com/Codete/Codete. You can download it now because it's really, it's not heavy. It's not heavy. It's about 400 kilobytes. You want me? Okay. If you don't have the container, you don't have the image, or you have any issues, you can still go here and open the notebook. And you can just follow through the notebook here, right? Go through. I will obviously explain everything, go through. Anyway, you can download it after the workshop, go through at home, test it out. Yeah. Okay, cool. So you know how to actually get the notebook, right, on the container. I don't need any headset, right?
No, it's okay.
It's fine. It's fine? Yeah. He said it's fine. That's good. If you don't want to use Docker, Git on your container, you still can download. Get the Jupyter Notebook and use your command line to copy it to your container, right? How to do it? Docker PS. This will show you. This will show you what kind of containers you have. I have two actually running. One with the idea of this here, and the second one here. Some Cisco training container, whatever. So I have two containers here. You can actually do it like the following. Docker copy the file name, like whatever, ODX. And here you get the Docker container home for the workshop. Here we go. And this is how actually you can copy your data to your container. Anyone used Docker before? Can you raise your hand who's used Docker before? Yeah, that makes sense. There are still some still place here in the front. Yeah, all in the back. Okay, cool. So that's it when it comes to the environment setup. Let's go to the slides. So yeah, I will talk about NLP chatbots. As Lars mentioned, I wouldn't say I'm expert. I'm doing machine learning for about 12 years now. so I have some experience in machine learning, let's say. Not this direction. Here we go. So, just a few words. I have a PhD in computer science and artificial intelligence, doing some O'Reilly trainings. Anyone know O'Reilly? You know, yeah, the guys with the boots with the animals, right? Yeah. So I'm doing training for them. And as you see, I was publishing. I did a PhD in artificial intelligence, actually developing some algorithms for skin cancer detection. So skin cancer detection. Now we are able to detect cancer on an early stage, skin cancer, so specific one. And anyway, after the workshop, if you have any questions, here's my phone number. Don't use it too often. Here's my email. You can use it often, more often. If you have any questions, just drop me an email, call me. I'm still here until the evening, so I can answer all of your questions. Any issues so far? Questions so far? Any?
So when starting the Docker container, do we need to do some port forwarding or something, or just start?
Yes, you should do. I forgot about it. That's true. Let me show you how to do it. Actually, you only need one port for the Jupyter Notebook. Here's how to do it. Run. It's 8888. And you can, let's say, whatever. And then you obviously need to give that Docker image. It's workshops, latest, bash. If you ask for a token, because if you run the Jupyter Notebook, sometimes I'm not sure if this container does have the password or not. If you have it, if you ask for a token, let me show you how to solve it. Let me use one of the Docker that I have here. Here we go. So you do it with the command here to go to the shell, right? If you're in the shell, you just type Jupyter Notebook list. You have a list, and I don't have here the token, but if you have a token, it's visible here on the right. So it's visible here on the list. Just copy paste token, log in, and that's it. You are in. If you have the problem. Cool. So, chatbots and buzzwords. I'm doing machine learning for years, and when I started doing machine learning as a company 8 years ago, I came to some customers asking them, well, I see you need some machine learning stuff. You need some machine learning solution. This will cut your cost or increase your revenues. You can imagine what they said. Ah, crap, we don't want machine learning. It's worthless. As you probably know, now machine learning is one of the coolest buzzwords. Everyone wants to do machine learning, deep learning, artificial intelligence. Well, many companies actually want to do it. The thing is that it's a buzzword. It became a buzzword like blockchain, like big data, like IoT, and many others, right? It's it's a bad thing because at the end it will actually be bad for machine learning and for data scientists, because many companies will actually figure out that putting more money on data science doesn't make any sense. Let me actually tell you a story. I was at a conference in Berlin in May this year, Race of AI, and we had a booth there. By the end of the conference, one of the directors from a company from Silicon Valley came to us. We talked some about the business, and then he told me a story about his customer. One customer came here asking about a machine learning solution. He said, okay, you have $2 million on the table, please develop this AI solution. Okay, so he took the money, they have developed the solution, they have implemented it, deployed it in production, they tested it, it is working. Right? Cool. But the guy, the director of the company, figured out, well, it is an app that actually was replying to emails. Or let's say it was kind of a customer service bot, actually replying to the request. And he figured out one thing, that the bot was responding for about 50 emails a day. And he came back to the customer asking them, why? Why did you spend $2 million for something that actually you can hire someone to respond to the emails? And it will be way cheaper because the person will spend 1 hour of the working day just to reply to emails and do something else for the rest of the time on a full-time basis. Why did you spend $2 million just to do something that is, doing something same, even worse because machine learning isn't perfect, right? And he said one thing. Now we can say that we use artificial intelligence on the company. And this is the only thing actually why they spent $2 million because of PR. Because they want to say we are using machine learning now, so we are cool. We are using blockchain, so we are cool, and so on and so on. We as a company, we have many customers in Berlin. We have also an office in Berlin, and there are many startups, and I'm also attending many startups events. And you can imagine how the people try to combine different buzzwords to make the startup sound more, cool, that they are doing something like rocket science, like put together blockchain, machine learning, and some IoT, and together we are, buzzword-driven startup, and we get some more financing. It's not really true. So please be aware of that. That it's not really. That also, chatbots is also a buzzword, right? Okay. So now chatbot. This is just another interface how we communicate with the customers. It means we had in the late 90s, let's say, we had the web interface, right? This is when actually everyone started to use websites to communicate with the e-commerces and buy something, get some news and so on. Then we moved to mobile interface, everyone is using mobile apps, right? And now we're moving to the chatbot. It doesn't mean it will replace, but it's kind of working together, right? So now we have the chatbot interface, the conversational interface that allow you to chat, to communicate with the customer and get more information from the potential customer, to be more adjusted to it, to the customer, and some more action. Anyone have developed any chatbot before here? One person? Anyone else? Oh, 2 persons. Oh, okay. Fine. You should try it. So there are different types of chatbots. You have depending on the interface. You heard about Alexa probably, right? So it's you can talk to Alexa, get some more information from it. You have bots depending on the privacy. We have some customers that are actually doing some fintech. They are banks. They are regulated, and they are not allowed to use any tools that are not installed on premise inside. Right? So they cannot use Dialog or any other tool that actually is online, like API. So there are 2 different types of chatbots in this case. We have online and on-site or on-premise chatbots. So we can only use the open source tools that can be installed locally. And depending on the usage, you have the superbots. Anyone knows an example of a superbot? You use it probably on databases. Google Assistant, maybe, Alexa, Siri, right? It doesn't matter if you're asking for the weather or your schedule for the day, or if you're asking for the recent Champions League scores, right? It doesn't matter. This is a superbot because it covers different domains. And there are also domain-driven chatbots that are specifically used for, and you can use it for some specific domain. It means, I don't know, let's say you have some Slack chatbot that is actually, doing some work for you when it comes to the content integration tool and so on. For example, here are some actually examples of the platforms. As you see, there are many. This is not the full list of the platform implementation. Yeah, so obviously you have Microsoft, Google, Facebook, Apple, and so on, right? And yeah, that is all. Yeah, as well, it's Google. So, and this is Chatbot actually, so this is really cool. And there are many platforms actually. You can use them to build your chatbots without actually writing too many lines of code. Right, so just clicking and that's it. In most cases. Do you know this guy? Who is it? Cool. Interesting, I didn't know it. That's good. So Alan Turing, obviously this is the godfather of the artificial intelligence. And he has invited or proposed the Turing test. Actually, and it's saying if the artificial intelligence can be actually, you can say it's really artificial intelligence. In the meaning, it can be replaced, a human. How do you think? Are we already there to replace the humans with artificial intelligence?
No, they're not big yet. Maybe we have the technology, but it's not bad yet.
Okay, so they are not intelligent yet. Most of you said that they are not intelligent yet. Okay. Yes, that's true. I mean, that's true. I think that's true. We are not yet there. I mean, there are some solutions like Alexa, like Siri. We can say, okay, they are intelligent. But how can actually figure out if the thing that is behind it is artificial intelligence, a computer, or a human? That's too hard. How do you think? An easy check how to do it. Because the Turing test is about who is behind, who is actually the person who I'm talking to. And if you're not able to distinguish if it's a human or artificial intelligence, or a computer, then you can say it's artificial intelligence. And how do you think? How can we check if it's a computer or if it's a human?
You asked it.
Yeah, but I can ask about weather. Person can say the same like.
You asked about physics.
It's a game called Imitation Game, on which this is based. Imitation Game. And it was a social game in the Alan Turing time. And that's where we got the idea of the test. So
Yeah.
we would close people in a room, and somebody had to ask them and guess what they were.
That's true, but there's a really simple way how to check it.
Ask it to be creative.
You can do it with the generative models already. I will tell you more about it later. Let's imagine a thing.
You got the power in the room and see if it's good.
Yeah, if you're allowed to do that, yeah, for sure. Let's imagine you're asking for what's the result of 125 multiplied by 2047 divided by 12, whatever. A computer will do it like that because they're good at counting. They're good at math. People, not really. I mean, yeah, if you study math for 5 years, then yeah, maybe you can do it quite fast. But usually people don't calculate so fast, right? This is a very simple task how to actually check.
But you can fake that out. So you can fake that out and then
Yeah, you can do a sleep, right? And obviously,
just say I'm not good with numbers.
yeah, obviously you can also do it, fake it in somehow actually make it stupid, make the artificial stupid, like in the way like human intelligent, right? To make it more like, oh, I don't know how to calculate this kind of numbers.
Make it have spelling mistakes as well.
Or spelling mistakes, exactly. But usually this is the test that actually works because the people actually who develop chatbots, they don't think about because this is something that it's not really important to really go in the direction of adding some sleeves in some cases, right, or typos.
How about holding an object and then putting it into your hand and asking, what's the object in my hand?
But it's no problem if you have the camera.
Yeah, but it's in the head.
But it saw it before, so you can use it with our convolution neural network to figure it out. I will show you that in a minute. It's something. Yeah, it's like Google Photos. Everyone knows Google Photos, right? Yeah. So Google Photos is if you put some images. Let's say you just took some hundreds of images, but you didn't give any description of the images. Any description. And you put it all in Google Photos. And there are some images with a dog on it. And you will type dog in search. They will show you the images with the dog, even if you didn't give them a description. How? Because they are trained on many images and they know they are able to figure out if there's a dog on the image or not. This is something we have already solved. So there are different types of chatbots that we are currently implementing. During my training, one of the training that I'm doing for O'Reilly is I'm actually showing 3 types of chatbots. The rule-based chatbot, this is the simplest type of chatbot, where you have a set of rules. Okay, I'll explain it in a minute, but you have a set of rules and responding to rules. So it's kind of a Q&A table with 2 columns, question, answer, trying to fit to the question and then responding to the answer. We have the retrieval, actually the smart machine, retrieval chatbots, where they use some machine learning behind it, respond, so they get the intent, what the user want to actually, what he's asking for, she's asking for, and based on that we are able to respond. I will show you an example in a minute. And you have the generative chatbots. So the chatbot is actually generating the output based on the history, but they are. Any questions? Did I say something wrong? Cool. They are using deep learning for generating totally new answers that were never given to the chat to the database. So it's. I will show you some examples later. So different types of chatbots. Yeah, rule-based. As I mentioned, I have a set of phrases, set of answers, trying to figure out the phrase and then giving an answer. How you would like to check what is the answer? Any ideas? Let's say someone is sending, the user is sending a question, and you need to figure out if we have it on a list, how you would do it. The obvious answer is some regular expressions, right? But we know it's not the perfect solution. I will show you some better ones. And depending on that, we are sending an answer. Obviously, if we don't have any rule here, then we are giving our response. Sorry, I don't understand your request, or something like that. So, some examples of word and sentence comparison. So, because we are comparing different sentences or words, there are actually plenty of such methods. Levenstein, for example, does much rating approach comparison, Gestalt, Magic, and so on. There are 2 libraries that you can use for that. Yeah, this will. Let's move to now to show you some examples. Don't worry, I will share with you the slide as well. Here we go. More example is, in this case, yeah. So actually you can use regular expression to divide the sentence into the words, for example, is one of the things, or use some more specific regular expression for that. And you can also use tokens, I will explain in a minute. Or you can also use some methods to compare. Here we go. It's sentence extraction. Yeah, exactly. here's an example. Here we have training and trains. How we compare it? These are the strings. So we need to compare what is in a string. There's a good example before. Let's imagine we have our word developer. Everyone here will think about a software developer. If we hear developer, we think a software developer. But the people outside of IT, if they hear, some of them at least, if they hear developer, they think about someone who is developing the buildings, right? Someone that is doing in construction. And if you go to textbook one of the library that we are using here, if you go to dictionary and ask for developer, you will get two answers to the description of the word of developer, right? So it's not so easy to figure out the meaning of the word in such a way. And it's also not so easy to actually compare the words as a strings, like here. We have training and trains. And based on this method, they are quite close, 0.721, between 0 and 1, so it's quite high value. Right? 1 means they are the same, 0 means totally different. Right? It's quite high, but you know, the training doesn't have too much in common with trains. Right? So it's not the best solution, but we can do it. And in some specific cases it makes sense. There are some other methods like the Levenstein distance. But also in this case, if we compare training and trains, we get a value of 0.625, which is quite high, and we still know that it's not really a good solution. So the neutrino-based chatbots, if we use this kind of a solution, they are quite not really intelligent, I would say, right? Because they are not really giving us the usual compliance. So that's why we use NLP. Anyone use NLP before? I know you two used before, I guess, because you did some chatbots in the past. Anyone? Okay, so 5, 6 people. That's good enough. Anyone use more than LTK? Anything else than LTK? Because LTK is the most common. Okay, cool. So I will go through some of the tools. But the NLP as a term is a wide term that actually is describing not natural language processing, obviously, natural language understanding, and natural language generation as well. So we are also generating the that one I can talk about. So NLU, NLG, NLP. NLP is I would say the term that covers all of that, all the terms, and you use is a part of it for understanding what the person is saying, what the user is saying to us, so understanding the language. And natural language generation is about generating answers. Generating answers, I will show you some examples later. So the 3 most popular methods of NLP is tokenization, is the memorization, and the stacking. 3 methods that are the most popular to operate on the text, on language, to get more from the language, to get the understanding. Let me show you an example. Okay, let's go up, understanding, tagging. Here's an exercise for you to do at home as well. Let's go back to the exercise from the regular expression. So, not the sentence, but we have a sentence and we need to split it into many into words. With our regular expression, it's quite easy. We just split it. What's wrong with this vector, with the list? What's wrong here? I mean, the example 11. No. Exactly, the dot. Why? Because the dot is also an information. It is very important. we have a dot that is saying this is the end of the sentence. Whatever comes next can be in the same context or not, right? So we can do it in this way. We can also split the whole sentence, or like here also using other actually other patterns like here, just to go through and actually split the whole not just one sentence but many sentences into actually a vector like here. You can also split it into sentences like here, right? You have the whole text and just split it into sentences.
Well, I don't get this photo.
Is not working?
I don't know what to do to get this.
You have to upload the file from it.
Let's do the following. I will go through because we are running out of time.
Okay.
And after the workshop, we will sit together. I will show everything how to do any issues, okay? I want you, every one of you, to actually go through, understand everything. But if you have any issues, let's meet after the workshop in the lobby or here. I will help you, really. If there's anything that isn't really working. It is working for me. So you can do it this way. We have also some other actually regular expression methods that you can actually use to work on text, right? But as I mentioned before, it's not really the best solution. So one of the basic operations that actually is used in natural language processing is the tokenization. Tokenization is dividing the sentence, the text, into tokens. Not words, but tokens. You see the difference here? The dot is a separate token. Because it's important, it's a punctuation mark. And it's important for us to actually get to know what's in it. You can also actually use tokenization to divide the text into sentences as well. So you can even more actually use some, I would say, custom tokenizers. So build your own tokenizer. Like here, the tweet tokenizer. Because as you probably know, tweets are a bit different. They are small. I mean, they're not too long. And they have some emojis inside, they have some hashtags and so on and so on. So there is a different tokenizer that you can use specifically for this kind of text because it should be handled differently. Right? You have all the emojis here taken separately. Even a dot or a semicolon is something different. I mean, can be a different token. Right? Or you have the hashtag. And you have different kind of tokens, actually, tokenizers, actually to develop. That actually you can use. You can also develop your own tokenizer. Here's actually an example for you to build a tokenizer. But I will leave it to you to do it at home because we are not even in the middle, and we almost, we are running out of time. So the other thing is tagging. Tagging means, what does the word really mean? Right? If it's a noun, if it's what kind of noun, if it's plural or singular. So it's not really part of speech, but well, actually it is part of speech. So depending on that, what kind of it is, you will get part of speech here. And you have, this is just a short list of the tags. The full list that you have is here. As you see, there are many tags that you can actually add. So you see it's a verb, it's a different kind of verb, right? What else do we have here? You have the nouns, you have the adjectives, and so on and so on. So this is important if we are actually dividing the sentence into smaller parts, trying to understand what the user actually said. Right? And the tokens for here actually for text 6, this is something that actually you can use from NLP. NLTK is a library where actually you can, they have some, it's called Corpus. It's just a book that actually you can use for training. You know, see it here? Okay, and it's already downloaded. I mean, in your container. It's downloading during the building of the container, and you see a couple of books here, like Moby Dick, like Wall Street Journal, even the Bible. And you can actually go through and use the corpora actually to go through and check the number of some words, what kind of where actually they are in the text, and so on. Here's also an exercise about money. To get the money, wallet money from the Wall Street Journal. And also you can build your own corporas, like here. This is a Trump speech. This Trump from the US. A speech that he did in 2017. And based on that we have created here a corpus just for training purposes. And here you have the Gutenberg data set, I mean the corpus. As you see a couple of texts here. And what we can also do with NLTK, get to know what kind of words are the most popular or most used in some specific text. Like here in the Bible and then Shakespeare. So how many words. And you see and, I, Lord, God is the most popular word used in this text. Why we are doing it? Why we are measuring how many words of God are in the Bible or any other text, any text? Why is it useful? First of all, what is it about? Right? If you have God and Lord,
Game of
can
Thrones.
give us. Yeah. So you have a limited set of books actually, or series. Actually, you can say Lord and God are together. But actually, we did our research on the text of songs recently, and we figured out that heavy metal, the black metal, I mean, had the most occurrent. The word is actually used the most is actually God and devil in the text. So it also gives something to think about. Okay, tokenization is something that I said already. So tokens and tagging is one thing. What we can also do is well, another thing is a Unicode that we have issue. Romanian language also has some specific letters that are not available in different other languages, the same as in Polish language. And when we compare, we would like actually to, let's say, if you have a C with a comma or E with a comma on the top or somewhere else, we'd like to move it to our text without it, just to clean it up. So we can also have some kind of a tools like a Unicode tools and some normalizing methods to to make it like that. Here you have something in Portuguese and you have something in German without all the umlauts, commas, anything that you have in the specific letters from the specific language. Okay, so lemmatization. Lemmatization and stemming, they are similar, but they are not the same. These two methods are about getting from some words of the same meaning to get to the root or to the main word. Like here we have do, does, do it. But it's do. It doesn't make any sense if we count how many do and doing we have in the text. Right? It's important for us to actually get how many do's we have because it's the same word. And lemmatization and stemming give us the understanding of, allow us to do such an operation. Like here, we can actually take the root as a verb or as a noun. Here, as you see, depending on that, what kind of parameter, what kind of part of speech you give as a parameter in the lemmatization. Okay, this is one thing, and this is most it's most common to use vectorization than stemming. Here you see why. There are different stemmers or stemming methods that we can actually use, and they are not really doing from doing do, but they are just cutting whatever is not really needed, and actually going to the root, like here. See? They cut the S to D, as in this case. It's not proper, like this is how it works. We have an E, without E, you have the S, instead of usage, right? And so it's cutting to the root. What makes it easy then to work. So this is what stemming is about. What you can also do, okay, before we go up to the natural language understanding, I would like to also to explain something about machine learning. Sure. Can we? It's too tall, or is it? Sorry.
Maybe the whole hair of the. Anyone?
Okay. Let me turn it off. No, it's the projector. Nice try. I had one of the situations a couple of months ago. Actually, the projector to turn it off. And I was actually talking about the slides, about it. Okay, so anyone one of you used any machine learning method before? I guess some of you did, right? Just to be clear, machine learning is not the opposite to deep learning. Because there are some people saying, okay, machine learning is dead, now deep learning is ruining the world. Well, it's true that deep learning is ruining the world because many methods are actually deep learning methods, but deep learning is a part of deep learning. And machine learning is a type of implementation of artificial intelligence. So, yeah. So it's not really in this way. And you have neural networks. This is a different type of machine learning method. You have deep learning methods. Convolutional neural networks are a type of deep learning methods. So how does it work? You have more than two phases, but there are two, I would say, major phases. It's the training phase and the prediction phase. The training phase is where you actually put the data in with the labels. What are the labels? How do you think? What are the labels? Exactly. So if you have a skin cancer detection algorithm, the label is if it's a cancer or not, and the data is the image, right? And you're putting into some feature extraction, or if you have deep learning, you're just putting raw data, getting the features, and putting into machine learning method. Then you get the trained classifier, and then you can actually easily predict to get the label. One thing to remember, the training phase usually is heavy. It takes a lot of time to train the model. The prediction usually is super fast. Because this is just a math function. We are putting some variables inside. And we are combining it with the natural language understanding terms to get more intelligent. There are three types of methods that are the most common three methods that we are using in natural language understanding. Part of speech that I already showed to you, known chunks, and name and entity recognition. So to give you an example, here's the sentence extraction. Here you have the speed of Trump, right? And we are using Spaces. Spaces it's a library framework actually. It's open source, and it is used for NLP, for NLU as well. And here we are dividing text into sentences, just like that. See, it's quite easy. And here you have also the part of speech, which is different to tag a bit. It's a bit different. It's more like It's more like more general, I would say, part of speech tag. So this is how we actually get the information from the tags. We have also the noun tags. Why do you think we should actually get the nouns from the tags? It's obvious, right? If we say, okay, it's the vice president, member, Congress, first lady, United States, we can actually think about what is actually speech about, who actually is the speaker, and so on and so on. So we just get only the noun from the text. But there are even better things like name and entity recognition, a better method, and this says more about the text. It's not a part of speech. It's more about the speaker. What is it? It's a person. Right? And with the name and entity resolution, it's recognition. Sorry for the typo. You can get the meaning of the word. It's a person. The Congress is an organization. America or United States, GP means a location. Right? And so on and so on. So we have different kind of entities, name entities that actually you can use to recognize what kind of what is the text about. Okay. So here's an example. This is from Karol, it's from Cruz, but sorry for the image. And yeah, because I'm doing from Karol usually, but it's O'Reilly. And as you can see, we are actually dividing the sentence into different meanings, different actually nouns or name and entity recognition. Name entities, just to get to know what is the text about. But as I showed you before, it's hard for the computers or for us to figure out the similarity between words just on strings. So how actually it should be done in a proper way? With word vectorization. What does it mean? It means we are replacing a word with a vector of numbers. So we are putting it in a feature space. And here I have some examples. The king and the queen, there's a relation between the two words, right? And you see that man and the king is kind of a similar, because they are closer, than the queen and the woman. You can also, because they are numbers, you can also do queen plus woman minus king, and you will get a man. Right? So you can do calculation on the words to get some other values from it, because we have numbers, right? And the same here. So walking, walk, swimming, swam, and so on and so on. So there are relation between the words in the feature space. So we have a vector. Obviously, this is a three-dimensional vector. I mean, three-dimensional feature space. So we have only three values. In real-world examples, the vectors are 10, 15-dimensional. When it comes to dimensions, it's very hard to actually put it on an image, right? If we had 10 dimensions. So I simplified a bit. And how is it done? There is one actually method that is used. It's a bag of words. It's something that is. So yeah, you have two sentences here. This is the vector of the first sentence. This is not the word. It's more the word vector. And here is the second sentence vector, and here the second vector. It's quite clear how does it work. Bag of words. I'm back, putting all words in it, and then counting the number of words, and then putting this is the first word, 0, 1, 2, 3, and so on. So 1, 2, and so on and so on, and checking what word is used in different sentences. So we can implement it like that. As you can see, we have different kind of vectorizers available. Here we have one of the vectorizer that is developed with scikit-learn, one of the most commonly used machine learning library in Python. And this is how actually you get the value from it. So these are the vectors from the 4, 5 sentences here above the class. And you have the, here you have the back. Right? Here's also a task, an exercise how to do it. I already gave you the solution. So how you do it, it's quite easy. Build a list, so build a list of words. And in the fit transform, this is a customized vectorizer. And the fit transform, we are going through finding tokens in the list, and based on the list, we take the index of the token in the list and adding a one. So it's quite clear, and obviously the feature is just return list of the words. So quite simple. Quite simple. But what are the disadvantages of this solution?
You lose the order of the.
This is one thing.
This will be.
Yeah. It's too small, but you don't care if it's big or not. Well, I mean, yeah, small is better, but actually if you have more information, you have more information. So it's, pros and cons. It doesn't really say too much about the meaning of the words. It wasn't me. There's a bit of TF IDF. Is saying more about the words in the text. Let's imagine we have a huge text. And what's the most common word in English? The, an, I, and so on, right? But if we count them, it doesn't say much, right? Because they are so common that we don't really want to do it. Obviously, we can just throw it away, but still we want to get more value from it. I mean, get more information from it. And to do it, one of the methods is TF-IDF, where actually TF is for term frequency, IDF is for inverse document frequency. Where actually we are counting the frequency of the term in a sentence and also the whole document. To get to know if what is the relation, and if the sentence doesn't appear too often, but it's appearing specifically in this term, in this sentence is appearing more often, or it's often in this specific sentence it is appearing, then it's more valuable than the, which is actually everywhere. So it's not saying too much, right? And there is a good example, but you have many other words that are just used. Let's say you have a documentation of some app or some API. So there are some words like API, endpoint, and so on. It's obvious, but they are used everywhere, so they aren't really meaningful. I mean, that's something that we use everywhere. So it doesn't say too much. And this is how you implement it. So I have really not too many equations here, just a few. This is how you count it with the number of accuracy of the document, of the word in the document J, so in the sentence, and here in the whole document. So this is the result for the 5 sentences, and you see the second word in the first sentence is more valuable than the first one. Right? Even if it's off in this case. But obviously, if you have a small data set, it doesn't say too much. In words, it's also something that gives you some meaning here. So of words, for example. You have 1, 2, 3, 4. 1, 2, 3, 4. It's A. So obviously, A, it doesn't appear too often here, but for whatever reason, it's more important for in this case than the other ones. I need to change a bit of the example to actually get rid of the numbers words. But word vectorization. Actually, we don't need to do it from scratch. Spacey, for example, does have already model with all the vectors of the words, and the words are compared based on vectors. Here I have an example. You have 1, 2, 3, 4, 5, 6, 6 words. See it? Okay, so I have a king, queen, horse, cat, desk, and lamp. And you actually compare it with each other to figure out which one is more similar to the other one. And here I have the king to king is obviously they're the same, so they're similar. King to queen is 0, 3, 3. But the king and the horse, for whatever reason, is more similar than the queen, right? Don't ask me why, it's spacey. So they used some text, maybe some Shakespeare, I don't know, and maybe the horse is more often used together with the queen rather than with the more often with the queen, with the king rather than with the queen. So this is how actually you can get. We can also compare the whole sentences, like here. So Cluj University is in Romania, croissant is baked in France, and Namur is a large bird. And you can compare it, and you see that, Cluj and croissant, whatever, the two sentences are more similar than Cluj and Namur, right?
So it's obvious when you compare two words how they compare the similarity, because they just do like a distance between the two vectors. But when
it's also a distance here, calculate off each sentence.
Right? How does it compute the vector for like a sentence based on the vectors from the
because
word?
you have doc to vec and you have word to vec. So you have different kind of vectors for different sentences. Here we calculate the vector for the whole sentence.
By like, summing up the.
It's not really summing up. It's more like kind of an average, I would say.
Okay.
But I can send you later on the whole equation for that. But I will show you a better example later. So we have an example here how to actually build a word-to-vec algorithm. Word-to-vec in this case, not doc-to-vec. And so we are using GenSim in this case, just for 12 different words. As you see, we use the TSNA method actually to reduce the dimensionality to 2 dimensions, just to be able to plot the words in a feature space, and this is how it looks like. So it's quite fast if you don't have too many words in the dictionary. But one example that I would like to show you also is this one. This is something that was done by the guys from the University in Warsaw. It's not word-to-vec, it's not doc-to-vec, it's GLOVE. It's a different algorithm for calculating the vectors. And you see the queen and the king, typical, good example. But let's empty it. Let's do the following. We have an x-axis and the y-axis. Let's say x is west-east, and the y is, let's say, country and city. Let's say we have a country, so let's say Germany, Berlin. I didn't train it. This is already trained vectors. I mean, it is trained already. And let's say we have France, Paris. You see? And automatically now it is more to the east, rather to the west rather to the east from Berlin. Obviously, it depends on the data. And another thing, what's more to the west or what's more to the east? Examples? Let's stick to the capitals.
Spain, Madrid.
Here we go. You see? Isn't it perfect? Any other example? Okay.
London.
It's UK or England? I'd say England. It's not really too west from France. It's more north, but we can think it's more west than the other ones, than Paris. Any other example? Someone said Moscow. Right?
Romania.
Bucharest with the H axis in
CH.
horse.
There.
Horse.
Yes.
This is the English version of the
Yeah.
Sorry. Okay, for whatever reason, I mean, actually it's true, it's between Berlin and Moscow.
Why is Russia below Spain? What's the distance from the...
Yeah, sure. So in this case, we have a two-dimensional space. That's clear. So we reduce the distance here. The other thing is that it's the vector that we actually calculated. So we have two values, and it's about the data that we have. So maybe the Moscow is less accurate. It doesn't occur so often like Bucharest or Berlin, or Bucharest is more accurate in the text. So it depends on the text on which text. So that's why the value can be different. It's not really. It's how Bucharest is more of a city. More of a city than Moscow. So it's more like you need to take a look on the x and y, axis, because these are also words that we are comparing to. So that's the other thing. So the data that you are training on is crucial. So based on that, we can get totally different results. Okay, we still have some minutes, a couple of minutes. So let me go back. Okay, so let's go to the retrieval-based chatbots. Anyone used Rasa before? Rasa, this is a startup from Berlin. It's an open source library. Actually, it's a framework for chatbots. They have implemented, you know Dialflow, right? From Google. Yeah, so Rasa is the open source version of Dialflow. In the simplest way, how I can describe it. And here you have actually, how does a retrieval-based work? Rasa is implementation. So this will actually allow you to build retrieval-based chatbots. And you have questions and responses to get actually that you are putting into the machine learning model, and it's trained to detect the intent entity. And based on that, you can actually give a response. Why we do it? Because if you understand the intent and entity, we can actually do some task execution on that based on the intent. So if we just give you an example, here you go. What are recent Champions League scores? And the intent is Champions League scores, right? Let me know. And based on the intent, we exactly know what to answer. Right? So it's about intent detection. And this is what Rasa is doing. And how does it look like when it comes to the context management? This is a difficult thing. When we talk, I mean human talk, now we can talk about the weather outside. In a minute, we can change the topic to Champions League. And a few minutes later, we can change to, I don't know, to chatbots. And so on, and then we can come back to the weather topic, right? So we can change the context. And it's really hard by the computer, by the chatbot, by the map, actually to figure out where we are. So let's say we have a chatbot saying hi. We are saying hi to the chatbot. And it's responding with something. And we are saying hi again. What do you expect the chatbot will respond to? Not again the same, because it will behave stupid, right? So it should actually respond with something else. And this is actually where the state is here important. So we are managing the state. Updating the state depends on the action. And the state is always updated depending on how the computation flows. So this is how actually Rasa also is working. It's quite easy to train, not so easy actually to manage with the state. This case is a bit more difficult, but this is more or less how does it work, and how does actually the intent discovery work? How actually we discover the intent? So let's say we have a text. What is the next training? So we're using TF, IDF, doc2vec, or word2vec, or n-gram model, n-grams to get vectors. Then we are using the classifier and training it with some analog of the vectors. And based on that, we are able, because we have the label, we have the intent here. So it's not deep learning. It's not deep learning. Usually there are some neural networks used here because we can change the method that is behind. I mean, in Rasa, you can choose the method you are using. One of it is a neural network, typical one. You can also use SVM. Anyone use SVM before? Yeah, but it's mostly used in image recognition actually, rather than text recognition, but it can be also used here. Okay, so we don't have too much time. You can also go through the notebook later. Let's go to natural language generation. How actually to do that? How actually generate text? There are a couple of methods. The simplest one is the Ngram model, where I showed it to you before. Oh no, I didn't. So let me show it to you. Now we are taking into consideration the words that are on the left or on the right. We have a window, it's the orange thing here, and we take the words that are close to our word, and based on that we do some relation between the words. And this is how actually we can build our method that is generating, and it's based on the probability here. So it's quite easy. You have also other methods like the recurrent neural network. You have autoencoders. You have generative adversarial network. So GANs. They are working differently. The two last are deep learning methods. Why recurrent neural network are used? Because you can actually put some input, like the orange. I mean, the purple one is actually the neural network actually is. They are the hidden layers that are actually generating the output. The blue is the output, obviously, and the orange is the input. So we can put whatever sentence we have, depending on that, what kind of vector we have in the input, and also depending on that, we can also do some an output. And because we have different strings, the sentences are different. From that, this is something where actually it's easily used. And there is a modification of this method. It's LSTM, where we have also some memory inside. It's a brain image here that is the memorizing the word, the whatever we have trained before, just to keep it for generating the words next. It's a better version of the REN network, but it's still it's not perfect. You have also the autoencoders. How can you think about it? Do you know how zip works? I mean, the compression algorithm, right? It's not exactly like that, but it's easy to explain it in this way. So you have some sentence, you are zipping it to a feature vector and then unzipping it at the end. But in the meantime, we are actually giving some noise inside just to get some new value, new output. And also you have GANs, where it works a bit differently. You have the generator and this discriminator, and the training is finished when the discriminator isn't really isn't able to figure out if the generator was actually it was generated with the noise or if it's a real response. And if we have to say, then we have the whole algorithm, the whole network that is trained, and then we are generating totally new answers. The generative models, the autoencoders and the GANs, they will give you always a different answer. So if you ask the same question, let's say you open two windows, and you talk to the chatbot here and chatbot here, and do the same things, ask the same questions. In both cases, you would get different answers. Obviously, they can be similar or even the same in some cases, like hi, right? But if they are more advanced, the generated answer is different. But to build such chatbots based on that, it's super difficult. It is done by Google, by Apple, by Microsoft, by Amazon. There are some open source methods that actually you can use, but it's really hard because you need to really have a huge data set to do that. I have trained such a model, and it took me 7 days on 40 GPUs on Amazon to train it. Obviously, the data set was quite huge. So it's really heavy computation here. Okay, we are running out of time, so let me just check if we have still something in the notebook. Here we go. Okay, some references here. I think we covered most of the topics. If we didn't cover something that you can actually go through it on your own at home. But I have some more slides here. So, some advices where actually you can use what kind of a chatbot. So the rule-based chatbot, the advantage is that it's predictable, it's simple, easy to debug, right? And cheap. So if you don't need anything complex, just use this solution. If you want to have something that's more advanced, you should actually use Rasa or similar tool to build retrieval-based chatbots. Where actually they are more intelligent, they can identify the intent. They are actually easy to train. They are not it's not so difficult to train such models. So to train retrieval-based chatbots, actually, when it comes to Rasa, even if you have 10 examples, it's enough to do some first training. So it's not a huge amount of data you need to use for the first training. So yeah, you don't need too many question and answers. It's way more intelligent than rule-based chatbot. And the generative-based chatbots, the most difficult, heavy computation, raw data. Well, the raw data is good. I mean, good because you don't need to extract anything. You don't need to, mostly don't clean up too much. And if it's done properly, it gives you intelligent answers. What means intelligent? The grammar is proper, the spelling is proper, the answer is logical, I mean, it makes sense. And they are the most, I would say, generic. This is the most generic solution, but it's really hard to get such a chatbot working well. And what are the bottlenecks? Well, rule-based chatbots are in many cases too simple to build, especially, well, they are good if you have a fixed scenario of questions and answers, then this is a good solution, but they are not really intelligent because of that. And when it comes to retrieval, they are limited to the question and answer, in the meaning that, the training, it's actually also something good because we are limited to the question and answers, but on the other hand, they are not generating. I mean, they are limited only to the data set that we have, and generative-based, well, heavy computation, the huge data sets, and sometimes it's unpredictable. The question is how to generate data sets. Let's say you start with building a chatbot, and you don't have any data. How do you think you can actually do it?
Get free books from the internet. Great.
That's great, yes. A better way? You take Alexa and Google. Let's talk together. Get the data feeds. It's automatically. You know, they're talking, hi, blah, 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 and so on. It's also good to start with something to get to the right position. But it's an easier thing to actually do some kind of a game between chatbots and anyways and data. So this is one of the ways to do it. Some advertisements actually. You can find me on another workshop on building intelligent chatbots in Python. Do you know Safari platform already? I'm there, December 15. Meet me there online. Or 2 days before, I also do show you how to build a sentiment analysis from scratch in Python. So you can meet me there. Do you know what sentiment analysis is? Yeah, so it's we are figuring out if the person who is talking to us, if the person is happy, not happy, whatever emotion is actually hidden in the text. Thank you. Any questions? For sure, have many questions. Yeah.
What do you want to do when you can use client
Yeah. When it comes to languages, it's a difficult topic because what? It's even a more difficult topic. Let me give you an example. We have Alexa. And I have also some notebooks for Alexa. Not here, but if you go through my GitHub account, you find also some Alexa notebooks. And if you, because Alexa is talking to you, so she's sending you an MP3 or WAV file with the sound. And there is a tool like text-to-speech by Google. That actually my GitHub account, you find also some Alexa notebooks. And if you, because Alexa is talking to you, so she's sending you an MP3 or WAV file with the sound. And there is a tool like text-to-speech by Google. That actually you can type something and it will generate you a WAV from it based on the language. And you can use different languages, even different accents. And let's imagine that if you take Alexa, use US English, it understands everything. If you change it to English, I mean the British accent, and make it slow, it's a bit slow, it starts not, it gets broken. I mean, it doesn't understand. Alexa doesn't understand you, even if it's English. When it comes to the other languages, like Romanian, English, not so common languages. I don't know about Romanian, I know about Polish, that it is supported by Spacey in the alpha version, so it's not stable yet. I guess Romanian as well, but I'm not sure about it. When it comes to the language like German, Spanish, French, there are many tools that are available in the market that you can actually use right away, and they are stable, and you can use it. But for the less popular languages, still we have an issue, and to be honest, it's hard to find the right solution. I mean, you can train models by yourself, or use some tools that are available for training models like Spacey, trying to build your own vectors for that, for language. So it's not an easy thing to do, and yeah.
So, as this is a hard problem to get with data, do you know any or have any creative idea to how to get, let's say, data to train a chatbot? Let's say you have Romanian, which is not a so common language, but you want to do a chatbot in Romanian. How would you go about getting the data for that?
It depends on the problem that you would like to solve. If you have a customer service, it's good actually to have some data from the company that is actually have already something, because usually chatbots are used to replace people, replace the humans, right? So if you have a customer service and they are chatting or talking, I mean, you have the voice, you can easily move the voice to text and then start the training. So, but they need to have some data at the beginning. In the other way, you need to use kind of a tricks like scrapping data or putting, Google Home with Alexa together speak. I'm not sure if they are available in Romania.
That's a problem.
So if they are not, then you need to get it from the company that you're working for on the problem, just to grab the data in the first place. There are some available data sets already on open source, but most of them are in English.
Yeah.
So yeah, language like Romanian or Polish or Czech, it's a difficult thing, and actually you need to work close with the company that is want to use it actually to first of all build a solution that will actually get the data for the training. There is no magic solution. Maybe our solution will be generating data. This is also something that you can do, but the problem with generating data, with the data that is generated, that you need to really work on noise in it, because it's like machine learning. If you generate that, you have some specific algorithm that is generating that, and it's the same, in the meaning that it's easy for the machine learning method to build. Not really. The problem is that it doesn't generalize well. It will only work for the specific data set that is generated. So it's not really, you need to work on the noising part of it just to make it different every time. Any more questions? Okay, if you have any troubles with notebook, with the container, you can talk to me now, and I will figure out. Any other questions? I'm available. It's on the GitHub. I sent the link. I showed the link at the beginning of the. It's on GitHub. GitHub/Codete/Codete Foundation. Yes, I can send it to you. I will ask the organizer to send all the links. Anyway. Okay, so if there are no questions, thank you. And I'm still here for you if you have any issues to solve, questions, anything. Thank you.